Hello and welcome to yet another episode of Basics Explanation, and today I want to talk about the different driver types used in headphones and earphones. I want to highlight their positive and negative sides, pro and cons, and talk about them, about the physics that is behind them. I'm definitely not a best explainer out there. There are a lot of popular scientific materials about that, but I still have nothing to review, so let's talk about the different driver types. I will try to keep the amount of physics as low as possible, but we need to understand a pair of basic facts. So, first fact is when current moves through wire, and actually analog sound is just a current, altering current moves through wire, and when it moves it produces electromagnetic field around the wire, and as current is varying, field is also varying. And that's the first fact, so we need to know about the electromagnetism thanks to Mr. Maxwell, Mr. Faraday and their complex equations and the discovery that we used so actively nowadays. And second fact, everyone also knows, is that similar poles of magnet attracts and opposite poles of magnets repels. So everyone knows that. So basic idea is how we can change this current in wires to some air movement. It's simple. We need some static magnetic field. So negative and positive. And it's some magnet that produces static magnetic field. And some coil or wire goes through this field and it produces its own magnetic field when sound or actually current that corresponds to the sound moves through this wire, and these two fields interfere and we've got some movement. So some magnets are distracting or repelling, and that is transformed to the movement. And basically it's 99% of different drivers use this effect in some way or another. And probably let's start with classical dynamic driver. I prepared some illustrations. This one is a horn-like driver that is used in the big speakers, but it illustrates the idea well, so no big difference. So as you can see, there is static magnet. It's usually circular, and it produces a static magnetic field. And we've got some diaphragm. It can be horn-shaped or it can be just flat. It's suspended on some kind of frame, and there is a voice coil located somewhere in this static magnet field inside. We need to apply the current to this voice coil and it will start moving back and forward. It will move the diaphragm and it will produce the sound. So it's very simple, but why do we have so many different headphones? Why they sound so different? There are a lot of aspects here, besides of course acoustic things like damping, open back, closed back design and so on. One of the factors that impacts the sound is that the diaphragm is not solid and uniform, and it can't move as one single piece, because we need to make it as lightweight as possible. Of course, we can make, diaphragm from some hard metal like titanium or some other really hard metal, but it will be heavy and more work will be required to move it. So, usually used more flexible materials, some PET films. Nowadays we've got more advanced materials like carbon nanotubes, beryllium coated PET and so on and so forth. So different complex materials that tries to make the diaphragm as rigid as possible and at the same time keep it lightweight. So we are pretty successful nowadays, not we, manufacturers of speakers are pretty successful nowadays, and there are a lot of good solutions, but they are expensive, and anyway diaphragm is heavy and it still can't move as fast as, for example, balanced armature speakers. So resolution of the dynamic drivers is a bit lower than other driver types, but anyway it's usually enough to produce a good high quality sound, of course. And another aspect that is magnetic field that produced by this circular magnet is not uniform, because it differs in the center and at the ends, so the movement is not totally uniform in this field. So there are some distortions and this causes some changes in the frequency response. But negative side of the dynamic drivers is a bit higher distortion, less linear frequency response. But first plus is that it can pump a lot of air, and we need that for good low frequencies. Also, it's pretty cheap technology because it's really well developed. And another plus of this schema is that it has almost linear impedance curve, and it's also important. Second, and often used in the in-ear monitor schema, is of course balanced armature driver. It's pretty simple, and actually, it's close to the dynamic driver, but there is a slight difference. So, as you can see, we've got magnets here and coil here, and actually coil not attached to the diaphragm, it attached to some usually P-shaped armature, and this coil moves this heavy armature, and actually it moves it in a uniform way, because with such magnets we can achieve more uniform magnetic field. And as this armature is more lightweight, it moves faster, and through some driver road it moves our diaphragm. And usually balanced armatures have their own enclosure, so with balanced armatures we don't care about the shape of the in-ear monitors, their materials and so on, because it has own acoustic treatment, and there is no need to care about the shell itself. So this schema gives us a few pluses. First one is resolution. Balanced armatures are crazy resolving, and also low level of distortion, because this armature is relatively heavier than the diaphragm. And for such construction we can achieve more linear movement of the diaphragm. So lower distortion, higher resolution. But at the same time there are a few minuses. First one is in this schema, as you can easily foresee, balanced armature can pump less air. This means more lightweight low frequencies, and probably you've heard some single or double driver balanced armature in-ear monitors. Usually their bass is faster, but at the same time it's sounding drier and less weighty. And another problem with balanced armatures is that they usually not covering the whole sonic spectrum. There are balanced armatures for high frequencies, for low frequencies, for mids. So you know what I want to say, and often solution for that is to combine few different drivers, sometimes using some crossover to split the different sonic frequencies. So few drivers for treble, few drivers for mids, few drivers for low frequencies. Actually, modern balanced armature manufacturers create them like a Lego, so they even offer different sets, like get these two drivers, add this one, and you will have a good full band speaker system. But of course there is still a lot of field for experiments, and in-ear monitors manufacturers do different experiments, like Ambient Acoustics from Kiev created 16 and 24 driver models. Actually, creating really multi-driver models allows to pump more air, and that's the main thing. Also, with some tricky schemas, it allows to reduce the distortions. But of course, if one driver can't pump enough air, just get 4 of them, for example, and you will have more weight of low frequencies. First minus of such idea is that it's expensive, and you know the current prices. And second minus is that balanced armature drivers usually have some really not even impedance curve, especially when some crossover is involved. And for balanced armatures, we can see that like impedance is like 18 ohms, for example, but usually this impedance is measured on the one frequency, 1 kilohertz, and often their impedance really varies from few ohms at low frequencies up to almost kilo ohm on the high frequencies or in the mid, so their impedance is not linear, and that aspect makes them really sensitive for the impedance of the source, for the impedance of the cable. So for the balanced armatures, it's better to get the lowest output impedance, and that's why actually balanced armatures are the most sensitive to different cable rolling. At the same time, for example, single dynamic driver models usually not so responsive for cable changing. So, next pretty commonly used nowadays thing is the piezo driver, and actually it's the single driver that doesn't use this combination of static and varying magnetic fields. Piezoelectricity is a really interesting physics effect that appears in some crystals, in some materials, and actually even in DNA. So when current applies to some material, it starts vibrating, and actually it works in another way. If you apply some force to this material, it produces current. So it can be used in both ways, as for example a microphone or some sensor, or as a tweeter. So basic idea is simple. We apply some current to special material and it starts vibrating. And usually it's vibrating on pretty high frequencies, and it's better on the high frequencies. So usually piezo drivers are used for some tweeters. Next, really popular in the high-end schemas is electrostatic speakers. Basic idea here is pretty simple. Let's take two metallic grids and put some thin film between them. Usually it's made of mylar or of some other material, and then we apply really high voltage to this grids or starters, and we apply the audio signal. Partially, as you can see, it's applied to this step-up transformator, and partially it applies to this mylar diaphragm. And what we've got, so this one will be charged positively, and here will appear the electrostatic field. That's why they call static electric field, so that's why they call electrostatic field. And current that goes through this diaphragm will cause the interference. It will start vibrating and we will get a sound. The plus of this schema is that we can make this film really thin and really lightweight, because it just a few nanometer thin or even micrometer thin film and without anything. And it just vibrates in this static field with high speed, so it's perfect for the high frequencies. It's pretty good for the mid frequencies, and this schema also works pretty well for low frequencies, but actually for low frequencies sometimes it's hard to achieve the good amount of bass sometimes, because it's sounding super fast and super resolving, and because of that sounding dry. And also this schema requires expensive amplifier with step-up transformator or just amplifier that produces really high voltage. Also, first models of such speakers were pretty hazardous because of high voltage used there. But nowadays they are safe because they're used really low current, and it can be just some rattling noise if something will short circuit the diaphragm and stutter. So no worries about the risk of electric shock. But actually on Head-Fi there was some feedback from some person who got electric shock from electrostatic headphones, but I think it's more of exception. And also there is so-called electret speakers, pretty close to the electrostatics, but the difference is that their film is made of special materials that hold the electric charge, and so it doesn't require this step-up transformator or some special high voltage amplifier. And last but not the least, and really popular nowadays, is planar magnetic driver. The idea is pretty simple. We can take the grid of magnets, 1 or 2, it depends on the goals that we want to achieve. With 2 magnet grids we will get more uniform magnetic field, but at the same time, of course, driver will become heavier, so we need to pay for something. And we need to take some thin film and put the conductive wires on the surface of this film. You can see this schema in a different angle. So conductive wires, we apply the current to these wires, we've got altering magnetic field, and it will start moving the static magnetic field. What are pluses of this schema? First plus is that magnetic field is almost uniform here, so it's easy to achieve almost linear movement of the diaphragm, especially when it has some special shape with some ribbing or something like that. So we've got less distortion, diaphragm moves in a more uniform way, we've got piston-like movement, so we've got lower level of distortion and we've got higher resolution. Main minus of this schema is that actually it requires usually more power to drive it. Not as much as electrostatic schemas, but more than regular dynamic and balanced armature drivers. But that's what everyone knows here, like for planar magnetic headphones we need more driving power. So planar magnetic drivers can be isodynamic or orthodynamic. It's basically the same, just a different shape of these conductive wires on the surface of membrane. Usually for the planar magnetic it has this shape. For the isodynamic it has some such shape like meander. For orthodynamics it's some kind of spiral. And if you've seen, for example, my Empyrean review, they combine these two shapes. So experiments are possible here. These drivers were invented, actually all of these drivers were invented pretty long time ago, but nowadays there are a lot of know-how and experiments considering shape of magnets, their location, different materials, different things. So there were no big discoveries recently in the speakers area, but at the same time there is a lot of improvement in materials, in making processes cheaper and so on. Also nowadays more popularity gains air motion transformer or Hale drivers. It's pretty close by the idea to the isodynamics, but just diaphragm is made like of film in this accordion-like shape and it starts moving like accordion. And of course, there are a lot of experiments with creating different hybrid schemas, like if you need more weight for low frequencies but more resolution for mids. Basic idea is combine dynamic driver and, for example, balanced armature. And if we know that piezo drivers and electrostatic drivers produce better treble, just combine 3 drivers, and the only issue that remains is actually the price. So as you can see, progress is moving. We're getting more and more affordable models with interesting sound. For example, cheap models with electrostatic drivers from Shure tape, interesting hybrid models from the IMR. They're using more and more advanced drivers. Lot of good hybrid and multi-balanced armature offers from Chinese in-ear monitors models, and actually recently Blon and other companies starting releasing more and more affordable planar magnetic headphones. They are not as good as models made by big brands like Hi-Fi Man or Odyssey, Meze and others, but give them about a year and we will have good affordable sound for less. So thank you for being with me, thank you for listening, and have a nice day.